Good morning, children. This is your favorite teacher, Satish sir. In this session, we are going to see very important chapter in kinematics, that is what? Motion in 1D. Kinematics. Motion in 1D. What is meant by motion in one dimensional? Very important here. Let us consider a particle is going only on x-axis. This is what x-axis, positive x-axis. This is negative x-axis. This is positive y-axis. This is negative y-axis. This is what horizon. Let us consider there is an ant going like this on positive x-axis. This is called 1D, one dimension. That means in one dimension we will consider, in one dimensional particle we will consider only few things beta, that I will tell you one by one. Motion in one dimension. One dimension means on only one axis. Y axis and Z axis we don't consider. We are considering only on x axis. Suppose you are climbing up, a monkey is climbing up. This is what monkey climbing up, going up. It is also 1D. Why? Because this is going only one direction. So, if a body is going only on one axis, that is called one dimension. In this chapter, we are going to read about one dimension. Very important few concepts I tell you in this session. First one, what is meant by distance? Number two, displacement. Displacement. Number three, what is meant by speed? What is meant by velocity? What is meant by acceleration? What is meant by jerk? Only these terms we are going to see in this chapter in a detailed manner. What is meant by distance? Before going to see all definitions, distance is denoted by s, or in some textbooks it is given as x. Displacement is also s. Then what is the difference, sir? Put a bar. What is meant by bar? It is a scalar, it is a vector. Distance has no direction. Displacement has both direction and magnitude. It has only magnitude. If a physical quantity having only magnitude but no direction, direction is not there, magnitude is there, that is called distance. Displacement has both magnitude and direction. Speed is denoted by v, velocity is denoted by v bar. Again here same difference. Speed has no direction, only magnitude. Speed is measured in meter per second. Distance is measured in meter, displacement is also meter. Dimensional formula also same, L1, L1. Displacement, speed equal to what? L1 t minus 1, this is the dimensional formula. Velocity unit is also meter per second. This is also L1 t minus 1. That means meter per second means L1 by T1. T1 comes into denominator, L1 by T1. So distance equal to speed by time. The speed equal to distance by time. L is nothing but distance, T is time. Acceleration is change in velocity by time. V minus u by t. We can write it as change in velocity by change in time. Acceleration is also vector quantity beta. Acceleration as the unit is meter per second square. Now, what is meant by jerk? Rate of acceleration. Acceleration is in a given time is called nothing but jerk. Now, this is what meter per second cube. Jerk as a unit meter per second cube. All these things one by one we will see in a detailed manner. Please note down up to here. Distance, displacement, speed, velocity, acceleration and jerk. Distance is denoted by s, displacement s bar, velocity v, speed v, velocity v bar, acceleration a bar, jerk j, acceleration by time. These are the important terminology we are going to define in kinematics. Now, go to next topic. What is meant by kinematics? What exactly kinematics is? Kinematics. Kinematics is the elder son of mechanics beta. Mechanics is a branch of physics. Mechanics is a branch of physics which deals with the study of motion of a body. Mechanics is the branch in physics. So many branches are there. Mechanics is one of the branch. In mechanics is generally classified into three parts. Number one, kinematics. Number two, dynamics. Number three, statics. Mechanics is classified into three types: kinematics, dynamics, and statics. What is meant by kinematics? Kinematics is the study of motion of a body, not considering the cause of motion. What is meant by this statement? Kinematics is the branch of mechanics which deals only with the study of motion of a body. What is the meaning of the sentence? See here. This is the road. On this road, one vehicle is going on. This is the vehicle. Its initial velocity is u. Initial velocity is denoted by u meter per second. After some time, the speed of the car is raised. Now the speed of the car is increased. Let the speed of the car is final velocity of the car is v meter per second. Here initial velocity u, here v. Whenever velocity changes, what will happen beta? By default, some acceleration is produced. Acceleration is denoted by e, meter per second square. Why acceleration is meter per second square? Acceleration is equal to change in velocity by time. Meter per second by second, second into second, denominators are same. So powers should be added, meter per second square. That is the SI unit of acceleration. Now to go here to here, it takes some time. Let the time taken by the car to reach from here to here is t second. What is the displacement beta? Here to here, displacement is s bar. Displacement of the car is s meter. Sir, how to measure the displacement? Center of mass to center of mass. Actually, here to here we need to check. We need to measure from center of mass to center of mass. These are the terminology we are going to use in kinematics. Once again, initial velocity of the car is u meter per second. Final velocity v meter per second. Acceleration is a meter per second square. Time is t second. Displacement s meter. These are the terminology we are going to use in kinematics. Please note down up to here. Next. What is meant by distance and displacement? Very important beta. Distance in bracket yes. Displacement yes bar. One by one we will see in a detailed manner what is meant by distance. Let us consider this is what Hyderabad. This is what Vijayawada, Amaravati. Two capital cities of Telangana capital and as well as Andhra capital I am taking, Hyderabad to Vijayawada. I want to go from Hyderabad to Vijayawada. How to go better? By bus, how to go? First of all, Hyderabad to Vijayawada while going, first I need to go to major cities I am telling. Suryapet to Jagapet, Kodad to Jagapet, like that, Vijayawada. This is the bus road route. This total path covered by the body is called distance. Distance is the total path covered by the body, which is 300 km. Distance is the total path covered by the body between initial position to final position. This is what initial position, this is what final position beta. The total path covered by the body between initial position and final position is called distance. Now what is meant by displacement? Suppose you are going for, you don't want to go in a bus. Now the shortest path from initial position to final position, you are going from Shamshabad airport to Gannavaram airport. You don't need to go all these paths. The pilot directly goes in a shortcut path which is a straight line. Straight line is always the displacement between 2 points. This is called displacement beta. So that it has some direction, so S bar. This is what displacement has, distance, this is what distance. Distance is S, displacement is S bar. From this you can easily understand that distance is always greater than displacement. Suppose sometimes bus route and flight route both are same. Sometimes there is a same path. Distance and displacement are sometimes equal. Distance is most of the times greater, very few times equal to displacement beta. Distance is most of the times greater, sometimes equal to the displacement. Once again, what is the distance? Distance is the total path covered by the body between 2 points. What are those 2 points? Initial position to final position. What is displacement? The shortest path between 2 points is called displacement. Distance is measured in meter. Displacement is also measured in meter only. Distance is a scalar quantity. Velocity is a vector quantity. Distance dimension formula L1. Displacement is also L1. Distance is equal to speed into time. Displacement equal to velocity into time. These differences I will write in notes. You also prepare notes in beta. Distance and displacement. Please note down notes. Distance as well as displacement. Displacement. S bar. This is what S. Distance, first point note down. The total path covered by the body between initial point and initial and final position. Between initial and final position is called distance. What is displacement beta? The shortest path between initial position, initial and final position. This is what first definition of distance and displacement. Second point, distance is equal to, what is the formula? Distance equal to speed into time. Speed into time. That means, suppose your speed is 60 km per hour. You travel 5 hours. Hour cancel. Denominator you can write 1. Hour cancel. 5 6 are 300 km, which is Hyderabad to Vijayawada. That is what distance between Hyderabad to Vijayawada. If you multiply speed and time, you will get the. If you multiply speed and time, you will get the distance. Distance equals speed into time. It has no particular direction. You can go in different routes. That is why distance is a scalar quantity. Here, displacement is equal to velocity into time. Here also I will tell you one example. Your flight speed is 500 km per hour or 300 km per hour. For our convenience, I am taking 300 km per hour. Time 1 hour. Hour cancel. Again you go in your distance, your displacement is 300 km. What is the reason? Again you got a same answer. What is the reason? Here, displacement is the shortest path. If you go in this way, you can go in 1 hour. If you go like this, it takes 3 hours beta. That is the difference between distance and displacement, very important. Distance is the total path covered by the body between 2 points. Displacement is the shortest path between initial position and final position. Distance equal to speed into time. Displacement equal to velocity into time. Next point note down. Distance is a scalar quantity. Distance is a scalar quantity. It has no direction. Displacement is a vector quantity. Displacement is a vector quantity. Distance dimensional formula L1. Here also dimensional formula L1. Displacement dimensional formula is also L1. Clear? This is about the distance and displacement. Now we will see some examples. If you do some examples, you will get more clarity on this. And one more, distance is always greater than or equal to displacement. Displacement is most of the times less than the distance, sometimes equal. These are the differences between distance and displacement. Now, one example note down. You also try with me. Question number 1. First question. There are 2 points beta A and B. A and B. There are 2 points. Now, this is the circular path. A path is going like this. Another time it goes like this. First time it goes from A to B in this path through C, A to B through C, another side directly A to B. Find the distance and displacement, first question. Number 2, find the ratio of distance and displacement. Try this beta, basic question. See, simple. First question answer, say this is what circular path. If it is a complete circle, we call it as circumference. If a body starts from A, again come back to A, we call it as 2 pi r. But he travelled only half distance. So distance is equal to what beta? Half of the perimeter. You can write it as pi r. Pi r is the distance. What is displacement? Displacement is the shortest path. Let this is the origin, here to here r. This is also r plus r, 2r. Here also you can take capital letter r. Now first question is done. Distance is pi r, displacement is 2r. Second question, find the ratio. Distance versus displacement. S by S bar. This is S, this is what S bar. Now tell me S by S bar, pi r by 2r. R cancel. Now pi by 2, which is equal to pi is to 2. Yes, distance is to displacement is equal to pi is to 2. This is the answer for first question. Clear? Next question, beta. Second question. You try once. Question number 2. Question rectangle. This is what on rectangle. These corners are called vertices. Let it be A, B, C, D. This is 4 meter. This is 3 meter. A boy, a person moves like this, A to B, then after B to C. Now find the distance and displacement of the man. This is what displacement beta. Find the question is find the question number 1. Find the distance and displacement of the person. Number 2, find the ratio of distance and displacement. This is the second question. Do it beta. Simple. Distance S is equal to distance is equal to what is the formula? Total path covered by the body. Total path covered by the body. Total path. What is the total path? AB plus BC. First he went from A to B, then after B to C. What is AB? 4 plus what is BC? 3. 4 plus 3 how much? 7 meter. This is the total distance travelled by the man. Now find the displacement. Displacement is equal to shortest path. Shortest path between 2 points. Shortest path is A to C. Shortest path is always a straight line. So A to C. Now you know very well this is 90 degrees. So this is a one in a triangle. If any one angle is 90, that is a right angle triangle. So this is a right angle triangle. Now this is what theta. This is the opposite side. This is adjacent side. This is hypotenuse. You can write it as Pythagoras theorem. AC square equal to AB square plus BC square. So AC square is equal to AB square plus BC square. So AB square how much? 4 square 16. BC square 3 square 9. So 16 plus 9 25. This is what AC square. But we don't want AC square. We want AC. AC is equal to root 25. Root 25 is 5. That means here to here the distance is 5 meter. You can easily understand that distance we got 7 meter, displacement we got is 5 meter. Which is greater beta? Distance is greater than displacement. That is what all the time remember. Distance always must be equal to, distance always greater than or equal to displacement. Sometimes it may be greater. In this case it is less. Now question number 2. What is that they are asking? Ratio. Distance by displacement ratio they are asking. What is distance beta? 7 by displacement 5. That means answer is 7:5 is the answer. S is to S bar equal to 7:5. This is what distance versus displacement. Clear? Please note down. Question number 3. Question number 3, same model, but this is homework. Question number 3. Draw a square. This is 5. Square means all sides it would be same. Name the vertices as A, B, C, D. An ant moves from, this is what ant moves from A to B, B to C, C to D. First it travels from A to B, then after it reaches here, then after C, then after D. Now the question is find the ratio of distance and displacement of an ant. Pause it and do it. How to do this? This is also a very simple question here. So solution, answer, distance yes is equal to total path covered by the body. Total path covered by the ant. What is total path? First it went to A to B, then after B to C, then after C to D. Square means all sides the length would be same. 5 plus 5, AB is 5, BC is 5, CD is 5. 5 plus 5 plus 5 which is equal to 15 meter. Each one take that meter, 15 meter. This is the total distance traveled by the ant. Now find out the displacement. What is displacement? Tell me. Displacement is the shortest path between initial position and final position. Shortest path between initial position and final position. Initial position is A, final position is D. This is the shortest path which is a straight line. Directly you can write it as AD. What is AD length? 5 meter. This is what displacement. Simple, right? Distance we got 15, displacement. Distance we got 15 meter, S is 15 meter, S ball is 5 meter. Now they are asking ratio. Second question is ratio. Find out first, in that only ratio, S by S bar is equal to 15 by 5, which is equal 5 ones, 5 threes, 3 by 1 can be written as 3:1. This is what S is to S bar. Distance versus displacement. Distance is to distance ratio displacement. 3:1. Next question here. Now, question number 4. Question number 4. Question number 4. Now, this is a cube. This is the cube. This is the cube. Now, cube means all sides same. Let this is length A. This is breadth also A. Height is also A. Now, this is one vertex. From this vertex, an object goes like this, beta. An object goes like this. Finally reaches here. A to B. First A to C, C to D, D to B. This is the total path covered by the body. Now find the distance versus displacement. This is the question. A. Find the ratio of distance and displacement. Do it, beta. What is distance? Tell me. What is distance? Distance is the total path covered by the body. First question answer say distance is denoted by S. Total path covered by the body. Total path covered by the body. What is the total path? Tell me, what is the total path? A to C AC plus C to D CD plus D to B DB. All sides cube same. A plus A plus A, which is equal to 3A. Now we got distance is equal to 3A. Equation 1 is done. Now we want displacement. Displacement is the shortest path between initial position and final position. Initial point is this, final point is this. This is the displacement beta. How to find the displacement? Simple. You need to know the vector logic. This is 3 dimension. It has x-axis, y-axis, z-axis. So that you note down the initial positions. Initially it started from here. So the coordinates are 0, 0, 0. 0, 0, 0 are the coordinates. Here, what are the coordinates here? A distance from x-axis. This is the origin. Suppose if you consider this is the origin, A distance is moved on the x-axis. So you can write it as A I cap plus B distance. This is called this is B. This is the C. This is B J cap. This is the C distance C J cap. But it is inside, so you have to write negative beta. Into the page is negative, out of the page is positive. So A I cap plus B J cap minus C K cap is the C K cap is the coordinates of the B point. Now how to do this? You know very well. A to B is the shortest path is AB. AB is equal to under root. This is x1, y1, z1. This you can write as 0 I cap plus 0 j cap plus 0 k cap. This is x1 I cap, y1 j cap, z1. x1 I cap, y1 j cap, z1 k cap. x2 I cap plus y2 j cap minus z2 j cap. Now how to find the distance? Shortest path. This minus this coordinate minus this coordinate. A minus 0 whole square. A minus 0 whole square is A square. B minus 0 whole square is B square plus minus C minus 0. Minus C whole square is C square. So A square plus B square C square. But cube all sides same height na? A. You can write it as A square plus A square plus A square. You can write it as 3A square beta. So root 3 into root A square. Square root cancel. So root 3A is the displacement. Clear? First write the coordinates where it started. It is started from the origin 0, 0, 0. Now final coordinates, right? It moved A distance on the x-axis and let this is B, this is C. This coordinate is B, this coordinate C in general. So it is inside, so C I am taking minus the distance x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square under root. This is the distance between the 2 points in 3 coordinate system. If you read vectors, the distance between 2 points easily we can calculate from here to here. It is a vector quantity. Final positions minus initial positions, the square under root. Simple. Now distance we got 3a, displacement is root 3a. Now we have to find the ratio. Distance by displacement is equal to distance. How much you got beta? 3a by root 3e. A cancel. Root 3 can be written as root 3 into root 3. Root 3 whole square again we get same. Root 3. Root 1, root 3 cancel. Root 3 ratio 1. This is what distance versus displacement. Clear beta? Once again, listen to me. Very important question. There is a cube. All sides same distance is present. Let the length is a, breadth is a, and height is also a. Height you can take the C is a. Now a particle goes from A to C. then after C to D, then after C to D. You have to find the distance and displacement. You know that distance is the total path covered by the body. Here to get A plus A plus A 3A, which is distance. Now the displacement is very important. Displacement is the shortest path between initial position and final position, which is A to B. So A to B, how to find A to B? First we need to understand coordinates. It started from 0. So x-axis 0, y-axis 0. This is the reference line beta. 0 I cap plus 0 j cap plus 0 k cap. Finally it is here. A distance on x-axis, B distance on y-axis, C distance on z-axis. So x2 minus x1 whole square, A minus 0 whole square plus B minus 0 whole square minus C minus 0 whole square, which is C square. But cube all sides, cube is not that no dice. All sides the distance is same, we are considering it as A square plus A square plus A square, 3A square, root 3 comes out, root A square is A, root 3A, this is what displacement, S bar. Now the ratio they are asking, S by S bar equal to 3A by root 3A, A cancel, 3 can be written as root 3 into root 3, 1 root 3 gets cancelled, S is to S bar equal to root 3 is to 1, this is what the ratio of distance and displacement in a cube. Please do it better. Next question, question number 5. Pause it and try to do it. Question number 5. Circular path, there is a circular path. This is the center of the circle O. Let the R, radius is R. Now a particle starts from here, or a bike rider starts from here. First he covered 1/4 distance. 1/4 of the 1/4 distance he covered. 1/4 distance he covered. A. B. Half distance he covered. C. 3/4 distance he covered. Finally, one complete rotation he done. One complete rotation. In all these cases, we need to find distance and displacement beta. Do it beta. A bike rider starts from point A. First he completed half rotation, 1/4 rotation, then after half rotation, 3/4, first one complete rotation. In each and every case, you need to find the distance and displacement. Very important question. You will understand all the concepts if you do this. First question I will tell you. Question number 1. This is the complete circle beta. 1/4 means what? Up to here, D. This is also radius R. Why? Because from circumference to center of the circle, always the distance would be same. So, if he come to same position, it is nothing but circumference of the circle, which is equal to 2 pi r. But what is the distance travelled from A to B? Distance travelled from A to B. Distance is the total path here to here. Total path is 2 pi r. If he comes back, it would be 2 pi r. Again, if he come back, but he travelled only 1/4. So by 4. If he started from A beta, again if he come back to here, that is 2 pi r. But he completed only 1/4 quadrant. So 1/4. 2 ones 2 2's, which is equal to pi r by 2. This is what distance from A to B. Clear? Now displacement. Displacement is the shortest path between here to here. What is the shortest path? That is always a straight line. So it is a vector quantity. He started from A, went to B. Now you know very well this is the angle between these two lines is 90. It is a right angle triangle. So OAB is a right angle triangle. You want A to B. Pythagoras theorem, apply Pythagoras theorem beta. AB square hypotenuse square is equal to remaining two squares. OA square plus OB square. So what is OA square? R square. What is OB square? R square. R square plus R square, how much? 2R square. This is what AB square. You don't want AB square, you want AB. AB is equal to what will happen? Under root 2R square. Root 2 comes out. R square square root cancel R. Root 2R. This is the displacement beta. Displacement is root 2R. Distance is pi r. First case is completed. First case is completed. First case distance is how much? Pi r. Here to here pi r. Displacement is root 2 r. Now case 2, half rotation is completed. We will do second one. Again we will redraw the diagram. This is what circular path. Center of the circle r. This is also r. This is point A. This is point B. Now A to B, distance we will find. Distance from where to where? A to B is equal to total path. Total path like this beta, A to B. If it is a complete circle, what will happen? 2 pi r. But what happened? He covered only half distance. He did not come to A. He is at B. Finally he reached B. So only half distance he covered. 2 to cancel. Finally it is pi r. Distance is pi r. Displacement from A to B. Displacement is always a straight line, which is A to B. Directly he is going like this. So r plus r how much? Straight line. R plus r which is equal to 2r. This is what second case. You do third case beta. Third case. What is third case? 3/4. Finally he reached here. See here. First one 1/4. Second one half. Next 3/4. What will happen 3/4? Tell me. This is what circular path. Origin started from A. Finally reached 3/4. 1/4 A to B. This is C. This is point D. Now he reached D. Now this is the total path covered by him. This is the total path covered by him. Distance from A to D. Distance from A to D through BC. What will happen? Tell me. 3/4 path. Total 3/4 path he covered. Out of 2 pi. If he reached up to here, we can call it as 2 pi r into 2 pi r. Total path is 2 pi r, but in that he covered only 3/4 part beta. So 2 ones, 2 twos. So 3 pi r by 2 is the answer. This is what distance travelled by the body from A to D through BC. Now find displacement A to D. What is displacement? Shortest path between A to D. How to find shortest path? Again, this is R. Circumference to center of the circle R. Again, we can take the same logic. It is a right angle triangle. AOD is a right angle triangle. Here hypotenuse is AD. AD square is equal to, again taking AD square is equal to AO square plus OD square. So R square plus R square which is equal to 2R square. But we don't want AD square, we want AD. AD is equal to under root 2R square. 2 comes out, becomes root 2. R square comes out, becomes 2R. This is the displacement from A to D beta. Very important questions. Last question is very simple. You try once. It reaches the same point. Then what will happen? See here, this is case number 3. Now, last case also I tell you. See here, this is the circular path, center of the circle. This is what point A, where the man started. Again, he reached the same point. I use another pen. So he started from here. Again, he reached A. What is the distance, beta? Distance from A to A. Distance is equal to what? Total path covered by the body. This is the total path covered by the body. Total path is nothing but circumference of the circle. What is the circumference of the circle? Total path which is equal to circumference of the circle. Circumference of the circle formula 2 pi r, where r is the radius. Now displacement A to A. Displacement is the shortest path between initial position and final position. Initial position A, final position is also A. There is no displacement, hence the displacement is 0. Very important question. Please note down. Next concept, very important concept beta. Till here we saw in a circular path, if a body covers 1/4, quadrant, half, 3/4 and complete circle. It is not like that. Now the question is little, I will make complex. This is what circular path. This is what center of the circle. This is 1 point P, radius is R. Same particle now reached here. Another point Q reached here. This is also radius. Now the angle between these 2 points is given theta. Now theta is the angle between initial position and final position. Now they are asking what is displacement. Find the displacement. How to do this? You will say displacement is the shortest path between initial position and final position, sir. So that initially it started from P, finally it reached Q. So this is the vector. Then how to find this length? This is the resultant. Let the resultant is D. You need to understand vector concept here. We need to apply vector concept here. How to add two vectors, beta? This is the first vector. This is another vector. Origin to P point, origin to Q point. How to add two vectors? Head tail concept. This is the head of the first. This is the head of the first vector. This is the head of the second vector. This is the head of the third vector. This is tail. See here, same diagram I will draw here. This is what first vector, or this is what resultant vector D. Resultant vector D. This is the second vector. Let it be R1. Let it be R1. This is R2. D. This is R2. R2. R1, R2. Resultant is D. Now tell me what is the relation between these three vectors? Second vector, this is the second vector tail, this is the first vector head. Head tail method. Remember beta, how to add two vectors means head tail method. First vector head must be added to the second vector tail. Okay, these two can be added. That means you can write it as R1 plus D is equal to resultant must be. If you add these two vectors, the resultant must be first vector tail to second vector head. This is called resultant. Actually, in this case, this is a special case, beta. If you add these two, you are getting the resultant is D. Now, same goes, but how to add this? If you want to add two vectors, head tail method, first vector head must be added to the second vector tail. So, R1 plus D is equal to R2. This is the actual relation. Now, we will get the relation from this. How to do this? Simple. Squaring on both sides. Otherwise, we will do one thing. Okay, let it be. R1 square plus D square plus 2 R1D is equal to R2. Otherwise, simple method we will do. Same method, R1 plus D is equal to R2. D is equal to R2 minus R1. We will send this R1 this side. Squaring on both sides. If you do squaring on both sides, what will happen, beta? D square is equal to A minus B whole square. A square plus B square minus 2R1 R2 cos theta. Vector method, beta. 2R1 R2 cos theta. Why cos theta, sir? It is not A minus B whole square now. In vectors, vector parallelogram, you need to draw vector parallelogram. If you want to add two vectors, again you need to draw. This is what first vector. This is what second vector. If you want to add these two, cannot be added. Why? Because tail. We want head tail method. This is A vector. This is A vector. This is B vector. Shift this B vector here. Now the resultant would be this one. First vector tail to second vector head. This is the resultant. This is the angle between two vectors. Similarly, the angle between two vectors is theta. Then what is vector parallelogram law? R square is equal to A square plus B square plus 2AB cos theta. R square equal to A square plus B square plus 2AB cos theta. Same thing I am applying here also. Observe carefully. R1 square plus R2 square minus 2R1 R2 cos theta. D is equal to what will happen, beta? R1 square plus R2 square minus 2R1 R2 cos theta. This is the important relation to find the resultant vector. Vector parallelogram law I applied there. Based on this, I will give one numerical now. Once again, this concept very important concept. Let us consider there is a point on the circumference of the circle at point P. It reaches up to Q. Now you know that in a circle the radius is always constant, so R is constant. The resultant is this one, initial position to final position, which is a straight line. Now I want this magnitude of this value. How to find this? First, you cannot add these two vectors, right? Because this is going up, this is also going far. Tail cannot be added. We need head and tail method. So that this is the resultant. These two can be added. Why? Because this tail is added to this head. So this is what R plus D is equal to this is R1 plus D is equal to R2. That only I wrote. R1 plus D is equal to. If you add these two, resultant must be first vector tail to last vector head. So R1 plus D equal to R2. R2 send R1 send that side. D square equal to R2 minus R1. Make do squaring both sides. If you do squaring, D square equal to vector addition R1 square plus R2 square minus 2 R1 R2 cos theta. This is the relation. This is the finding the magnitude of the resultant. Now one question note down it. This is what circular part. This is what center of the circle. Radius. This is another point. This is also R. Now the angle between these two is 120 degrees. This is what resultant. Now find the resultant. Simple. This is what first vector. This is what second vector. This is what resultant. Resultant is always from initial position to final position. Let the resultant is D. Now only we saw resultant D is equal to under root R1 square plus R2 square minus 2 R1 R2 cos theta. This is the formula to find the resultant vector of two vectors. D is equal to under root. What is R1 square? R square plus R square minus 2 R into R square cos theta. R square plus R square 2R square minus 2R square cos theta. 2R square is common. 2R square into 1 minus cos theta. 2R square comes out root 2 into root R square into root 1 minus cos theta is under 2 sin square theta by 2. 2 sin square theta by 2. 1 minus cos 2 theta is 2 sin square theta. In here 2 theta is not there, theta is there. 2 sin square theta by 2. Here root 2 into R square root cancel. So directly can I write that? Root 2 into R into again one more root 2 comes here sin theta by 2. Root 2 into root 2 2R sin theta by 2. This is the standard formula you need to remember to find the resultant vector in a circular part. Now apply same formula. D is equal to 2 into R into sin 120. 120 by 2 sin 60. What is sin 60 value beta? Root 3 by 2. 2 cancel. Answer is root 3R. This is the resultant of these two vectors. Answer is very simple. Root 3R. Practice here. Practice up to here. Any doubt, write in comment section. Next session we will see velocity and acceleration. Numericals on velocity, speed and velocity, acceleration, jerk. This is video number 1. Motion in a straight line. Follow and pause it. Write the question, pause it and practice it. All the best. God bless you. Have a nice day.